Hello, this video is going to be on section 6.5, which is titled Solving Square Root and Other Radical Equations, and the target is once again derived straight from the section title. It is to solve square root and radical equations. This video is strictly examples. There's nothing new that you will be learning, just kind of applying some algebraic tools to solve for certain variables within equations. So let's take a look at the first example. We have 3 plus the square root of 2x minus 3 is equal to 8. The very first thing you could isolate to get the x by itself is to subtract the 3 on both sides. So on the left we have 2x minus 3 equal to 8 minus 3, which is 5. Then from here, to get rid of the radical, we have to square both sides of our equation. The radical cancels out, so we're left with 2x minus 3 equals 5 squared, which is 25. Then to get rid of this 3, we add to both sides. 2x is equal to 25 plus 3, which is 28. Then dividing by 2 on both sides, we are left with x equals 14. Okay, when we are squaring a number right here, we are not making it plus or minus because any number squared must always be a positive, so 5 squared is only positive 25. Then just using algebra to whittle it down to get x by itself right here. The next one, we have 3 times the 5th root of the quantity x plus 1 cubed plus 1 equals 25. Now the very first thing we get by itself is we subtract 1 on both sides, and we are left with 3 times the 5th root of x plus 1 cubed equals 25 minus 1, which is 24. Divide both sides by 3. We still have the 5th root of x plus 1 cubed, and it's equal to 24 divided by 3, which is 8. Okay, this expression on the left can be rewritten in exponential form. Right now it's in radical, so to get it into exponential form, you take the exponent underneath the radical on the top of your fraction, and then the index, which is the outside of the radical, as your denominator of the exponential, and set it equal to 8. Now to get rid of this exponent up to the 3/5, you must do the opposite to that side, which is raising it to the power of 5/3. Now we raise it to the power of 5/3 because when we multiply these exponents, they cancel out and we are left with an exponent of 1. So on the left side we're left with x plus 1, and on the right side we have 8 raised to the power of 5/3. So once you convert it from radical to exponential, you raise this whole expression to the power of whatever fraction this is flipped. 3/5 is raised to the 5/3. Each of the 3 cancel out, and the 5's cancel out when you multiply them together. So we have x plus 1 is equal to 8 raised to the 5/3. And 8 raised to the 5/3 is equal to 32 if you use your calculators to solve that. Then here, one-step problem, subtract 1 on both sides, you get x equals 31. Alright, so the big step here is to get everything outside of the radical over onto the other side. So you're left with the radical and whatever's underneath it. Then you convert it to exponential form, which is the numerator, the number underneath the radical, then the denominator, which is the index. Raise that to the power of whatever fraction this is flipped. So if, say, it was 2/3, this would be multiplied by 3/2. Then you do the same thing on the other side. Raise that to the power of what you flipped. Reduce it down and solve for x. Same exact thing can happen to the example on the right. If we have 2 times the quantity x plus 3 raised to the 2/3 equals 8. Very first thing we can do is divide by 2 on both sides. And 8 divided by 2 is 4. And then since we have an exponent up to the 2/3, that means we have to raise it to the power of whatever this is flipped, which is 3/2. And the exact same thing has to happen on the other side. 2's cancel out, 3's cancel out, so we're left with x plus 3 equals 4 to the power of 3/2. Now you can do this without a calculator. You can take 4 square root, which is 2, then that cubed is equal to 8, or you can do the other way. 4 times 4 times 4 is 64 for 4 cubed. and the square root of 64 is 8. Either way, you'll still get the same answer, or you can plug it directly into your calculator exactly like this, 4 raised to the 3 over 2, and that will get you 8. Subtract 3 on both sides, and you get x equals 5. Okay, once again, raising it to the power of whatever this is flipped, reduce everything down to get x by itself. These next two examples, we're going to solve for the x, but what we need to do along with that is to check for any extraneous solutions that we might come across. So if we get 2 solutions, that means we have to plug them back in to see if both of them are correct, or if maybe we got one that's extraneous and doesn't actually work. So from here, I'm going to add 5 to both sides to get rid of everything next to this radical and get the square root of x plus 7 equals x plus 5. Then from here, since I have the square root, to undo this, I'm going to square both sides. And that means I will be left with x plus 7 equals, now the quantity x plus 5 squared is the same thing as x plus 5 times x plus 5. And if you FOIL that out, you will get x squared plus 10x plus 25. Now getting everything over on one side and solving for this quadratic equation, I'm going to subtract x and 7 on both sides to get 0 equals x squared plus 9x, since I subtracted 1x from 10, and then 25 minus 7 is going to give me 18. Okay, and I'm going to write it up here for some more space. And it looks like I can solve this by factoring. So if I multiply the 2 outside numbers, I get 18. 2 numbers that multiply to equal 18 but add to equal 9 are 6 and 3. So we have the factors x plus 6 and x plus 3 equals 0. That means since these are being multiplied to equal 0, one has to equal 0 and the other has to equal 0. So that means x is equal to negative 6 and x is equal to negative 3. These are both of my solutions. However, I do have to check for any extraneous ones. Now what makes an extraneous solution is if you plug this underneath the radical and you get a negative number underneath the radical, you will not get an answer since you cannot take the square root of a negative number. Or if either way they just don't equal to each other on opposite sides. So plugging in the negative 6 first, I have 7 minus 6, which is 1. The square root of 1 is 1. 1 minus 5 is negative 4, which does not equal negative 6. So my answer does not work. Now, I'm going to show the math right here for you in orange. The square root of negative 6 plus 7 minus 5 equals negative 6. Negative 6 plus 7 is 1. The square root of 1 is 1. And 1 minus 5 does not equal negative 6. It equals negative 4. So that is why this is not a solution. This is extraneous. Now plugging in for negative 3. Negative 3 plus 7, square root, minus 5 should equal negative 3. This is equal to 4. And the square root of 4 is 2. So 2 minus 5 is negative 3, which this one checks out. So this is an okay solution. Okay, so be sure you are checking for extraneous solutions by plugging them in, and if one side doesn't equal to another, or if you get a negative underneath the square root, then you cannot include it in your solution. It is an extraneous solution. Same thing down here with this example. Let's subtract 3 on both sides to get the square root of 5x minus 1 equals x minus 3. Square both sides to get 5x minus 1 equals, this is going to be x squared minus 6x plus 9. Then getting everything over to one side, I'm going to subtract 5x and add 1. So I get 0 equals x squared. Negative 6 minus 5 is negative 11x, and 9 plus 1 is 10. If I look to factor, multiplying the outside gives me 10. 2 factors of 10 that add up to equal negative 11 are negative 10 and negative 1. and they both equal 0. So since both are being multiplied to equal 0, that means one must be 0 and the other is 0. So I have x equals 10 and x equals 1 as my solutions. Now to check and see if any are extraneous, plug them into my original problem. So the square root of 5 times 10 minus 1 plus 3 equals 10. 5 times 10 is 50, minus 1 is 49. And the square root of 49 is 7. And this one works. 10 equals 10. Now let's check x equals 1. The square root of 5 times 1 is 5. 5 minus 1 is 4. Square root of 4 is 2. And 2 plus 3 is equal to 5, which is not 1. So that means this is not a solution. Your only answer is x equals 10. Very last example. We have the square root of 2x plus 1 minus the square root of x equal to 1. First thing I want to do here is to get this radical by itself so I can square it and it's a little bit easier. Sometimes you may subtract this on both sides, but it may make your problem a lot more difficult. Since this is easier to deal with, I'm just going to add square root of x to both sides. So that means those cancel out, and I have the square root of 2x plus 1 equals the square root of x plus 1. Now from here, I square both sides. When I square this expression, the radical disappears. And when I multiply these out together, it's the same thing as x plus 1 times x plus 1. So if I FOIL, my first is square root of x times square root of x, which is x. Outer is plus 1 square root of x, and inner is plus 1 square root of x. So I have 2 square roots of x, and then my last is 1 times 1, which is 1. I have 1s on opposite side that I can cancel out. Since I subtract 1, I do it same over here to get 0. And then I'm going to subtract this x on both sides to cancel out and get x equals 2 square roots of x. Alright, now whatever I can do to get rid of this radical is going to make everything easier. So to undo a radical, I'm going to square it, but I have to square everything on each side of the equation. I can't just square my radical and forget the 2. I must include everything on both sides. So that means I got to square the left also. Now the left is x squared, and the right, 2 squared is 4, and the square root of x squared is x. From here, it's a simple quadratic equation. Set everything equal to 0, so I'm going to subtract 4x on both sides. Now I can factor out an x from here, since they both have an x in common. Taking a look at the greatest common factor. Now since I have this times this equals 0, that means my first one can equal 0, and my second one can equal 0. Adding 4 on both sides, you get x equals 4. So I have two answers, x equals 0 and x equals 4. I'm going to check for extraneous solutions as my last step for this problem. Plug in 0 for my original case. 2 times 0 is 0. 0 plus 1 is 1. And the square root of 1 is 1, and the square root of 0 is 0. 1 minus 1 is 0. This one works. And now let's check 4 and see if we get an answer. The square root of 2 times 4 is 8, plus 1 minus the square root of 4 equals 1. This gives me 9. Square root of 9 is 3. Square root of 4 is 2. 3 minus 2 is 1. This answer works. So I don't have any extraneous solutions in this. They both work out. Sometimes you may get an extraneous solution, sometimes you don't, but it's always the best case scenario to check all of your answers to see which ones work.